Good evening, everyone. Thank you all so much for joining us tonight for the Multidisciplinary Senior Design Winter Showcase. My name is Kayla Carden, and I work in RIT's Office of Alumni Relations, and I'll be one of your hosts this evening. Before we kick off the formal program, I'd like to review just a couple of housekeeping items. I'm sure at this point in the pandemic, you are all very familiar with Zoom, but just in case, I'll cover a couple of items. So this evening's program is being hosted via the Zoom webinar platform, which means that our panelists will be broadcasting via audio and video. We do encourage you to communicate with us using both the chat and the Q&A features at the bottom of the screen. In particular, please enter any questions that you have for our students or our MSD hosts in the Q&A box, and we'll address those a little bit later in the program. Also, keep an eye on the chat box as we'll be sharing several links with you throughout the course of the evening. Lastly, we will be recording this webinar and all registrants will receive a link to it as soon as it's available. With that, I'm going to turn it over to the Dean of the Kate Gleason College of Engineering, Dr. Doreen Edwards. Doreen?
Great. Well, thank you, Kayla. Hello and welcome, everyone. I am so pleased and proud to have you join us for the Multidisciplinary Senior Design Winter Showcase. What we're going to be hearing about this evening are projects designed to address the need of a client. And our clients include outside companies, RIT faculty, nonprofit agencies, community members, and student entrepreneurs. The students who are working on these projects have spent an exceptional amount of time, 2 semesters and anywhere from 1,100 to 1,500 hours on the concept, design, project management, and documentation for their projects. What I find so exciting about this project is that we have an opportunity to observe students integrating their engineering knowledge, their theory, and practice within a structured environment where they get to work on teams just like they would in a real work environment. And how cool is that? We are incredibly proud of these students, and I strongly urge you to come and visit us on campus when campus opens back up. I think you'll be very impressed with all of our students' accomplishments. It is now my pleasure to introduce our moderators for this evening, Dr. Elizabeth DeBartolo and Don Pophal. Beth is the director of the Multidisciplinary Senior Design Program, and Don serves as a senior guide. Again, I'd like to thank you very much for joining us this evening and for all your support for this wonderful program. Let's get started.
Great. Thank you, Doreen, for that glowing introduction. So welcome, everybody. I'm going to tell you a little bit about senior design. Some of you who are participating might have graduated a while ago and things have changed over time. So senior design is a 2-semester course. It's required for 5th-year students in the College of Engineering from biomedical, computer, electrical, industrial, and mechanical engineering. And those students work together on teams over the course of 2 semesters. Sometimes we have students from other departments that also join in. We've had students from a couple from microelectronic and chemical engineering, but we've also had students from industrial design, imaging science, College of Engineering Technology. So when the project lends itself to collaboration outside of the college, we've had projects where that happens too. We take a systems approach to design, and the students start by defining the problem that they're solving. They move through the design process and they build or implement a prototype or a process, and then they test it before finally handing it back to their customer at the end of the project. And throughout this process, each team is mentored by an experienced guide. And most of our guides are either full-time faculty who have some responsibility allocated to senior design, or they're retired engineers from local industry who work as adjuncts and they mentor students through the design process. Next, Don is going to talk a little bit about where our projects come from.
So where do we get our projects? We run upwards of 100 projects per academic year through the MSD Senior Design Program. So we do a lot of soliciting of many different areas to reach out to industry in the community and other groups to bring the projects in. So many of our projects, upwards of 25 to 30% of them are sponsored by industry that we work with in Rochester and beyond. So a lot of projects coming in directly coming in through industry. Many times the students will be out at co-op and the company they're working for likes the students' work so much that they ask that the project continue through an MSD project, and we get projects coming in through that avenue as well. Community brings in a lot of projects through organizations, individuals, social impacts. We do outreach to healthcare applications and things like that. A lot of different projects and come in through many avenues like that. And faculty have a lot of supporting projects for R&D and for teaching efforts. And many of our projects are actually sponsored by students, whether it be student clubs like Baja, SBEX, or other student clubs, and also entrepreneurial students coming in through the Simone Center. We've brought multiple projects in through MSD that originated in the Simone Center through an entrepreneurial process. So how do we decide that the projects are appropriate for MSD? Well, we have a committee of folks which are made up of my fellow guides and myself, and that we look at it to scope the project and make sure that it's appropriate for a 2-semester project and that students can, number one, accomplish the projects in over 2-semester period of time. Number two, it's got an appropriate challenge to it with regard to the nature of the project and the technologies, things like that. We scope it for fit, obviously with an MSD and the goals, and also for staffing by discipline. So this is a cross-functional, multidisciplinary team effort. So we have electricals, mechanicals, biomedical engineers, computer engineering, and industrial system engineers working on one project. So we don't want to focus just a bunch of electrical engineers on one project. We wanted to make it multidisciplinary because, as Dr. Edwards mentioned earlier, this is the way industry works. You're working with cross-functional teams from that standpoint. The other thing is that students get to choose, they get to select to a certain level relative to what project they're interested in. So a survey will go out before the beginning of the semester, and they're asked if they have a preference on the projects. We try to strive to provide that preference. We can't always do that, but many times we do, and make sure that there's a match on the skills. And then there's also an issue of intellectual property that comes up sometimes from our sponsored projects, where intellectual property may be requested to be assigned back to the sponsoring project. So the students have to agree that, yes, I'm willing to work on a project for my intellectual property, if it's developed, will be assigned back to the sponsor company.
Yeah. And then once we have all that information in terms of, right, folks, faculty on campus have reviewed the projects and have a sense for what skills are required, and we have the input from the students on what their skills, interests, and preferences are, we match up the students to the projects to the best of our ability in order to make sure that the students are set up to be successful on the projects. It's an opportunity for students to meet new people. They learn how to work with other disciplines, which, as we've said, is what they're going to have to do after they graduate. And so with that, I want to talk a little bit about what these 5 students we're going to hear from today have been through in their senior design journey. So they started their projects in January. They were assigned to their teams, and they worked hard for the first 8 or 9 weeks of the semester, defining their problems, coming up with some high-level design concepts, and then they went away for spring break and they didn't come back. So they had a pretty significant upheaval right in the middle of their first semester. They had been gone from campus from March through the middle of August, and we had a few students who remained remote throughout fall semester as they finished up the project. So it's definitely been an interesting challenge for them. When they came back to campus, they had heavy work restrictions around their in-person activities with the social distancing requirements and people going around reminding everybody to put masks on and wear your face shields and keep your distance. And throughout all this, the teams really stepped up. They adapted to team members who had to continue to work remotely. We had quite a few students who were not able to return to campus in the fall, but they continued participating with their teams through the build and test activities. And throughout this, I really want to commend these students on the persistence that they demonstrated and the fact that they practiced good risk management and problem solving and managed to work within the circumstances that they were presented with. And really, when I look at the outcome of the projects that we're going to see today, I don't see a significant difference between this and the outcome of the projects that we looked at last December. So that's a testament to the students' hard work in coming out with an outcome that is representative of what would have happened during a typical semester. So with that, I'll introduce you to the students who are going to talk to us today. So we've got 5 teams represented. The first team is, and they'll tell you what these somewhat cryptic titles mean. So the first team is Team Rome, and that team will be represented by Owen Carr. Then we've got Josh Eng from COVID Crushers, Ethan Tola, whose team worked on a weight-bearing monitor, John Kaburski from the X-ray improvement team, and then Ryan Kent, whose team built a Robo Dreadnoughtus. So each of those teams is going to talk a little bit about their general project experience, and then what we'll do is we'll play a video that highlights each of the projects. So why don't we start with Owen Carr, and can you tell us, just briefly explain your experience and what may be unique about your project?
Hi, my name is Owen Carr. I was a 5th-year mechanical engineer from Vermont. Something really unique about ROAM, or the Remote Overhead Obstacle Avoidance Module, is the fact that we worked with a local nonprofit who intended to commercialize this product. And there had been previous iterations, but there were a number of different kinks that we had to work through in order to get this to that level that the customer required. So that was something pretty unique about our project.
Great. Next up is Josh Eng from COVID Crushers.
Hi, I'm Josh Eng. I'm a computer engineering student. And what was unique about my project was originally we started as 2 different teams of 4 people, actually competing to determine the best design solution for our project. But then ultimately we found out with all of the requirements and improvements that our client wanted to make for this project, we decided that it was best to combine into one single team so that we had enough people to handle the different technologies that we needed. So we had different requirements going from implementing wireless inductive charging to using Wi-Fi routers and signal strengths to figure out where our device is anywhere in a hospital. And then also being able to figure out what would be the best location to place different sensors and towers so that you can get the optimal disinfection configuration for this device.
Thanks. Next, we'll hear from Ethan, who worked on a weight-bearing monitor.
Hi, everyone. My name is Ethan Tola, and I'm a computer engineer at RIT. And I'm from New York City. And probably one of the most interesting aspects for the weight-bearing monitor on the project was trying to fit to a very constrained form factor and working with very niche sensors. And so the weight-bearing monitor ideally would be to provide a quantitative measurement for a typically qualitative process. We worked with the physical therapist who worked at University of Rochester Strong Memorial Hospital. And so this device would have to sit underneath somebody's foot to kind of give an accurate measurement on them, but also walk with them and be able to adjust to different foot sizes. And so it was pretty interesting coming up with ideas and at least trying to figure out how to work with all those constraints.
Thanks. Next up is John Kaburski, who's going to talk about his X-ray improvement project.
Hi, I'm John Kaburski. I'm also a computer engineer from the X-ray process improvement team. I would say our team is most unique because we were the first group to do MSD phase 1 entirely online this past summer. And then we also, on top of that, we have a team member from the RIT Dubai campus, which is an 8-hour time difference. Our customer wants to commercialize our solution. So we've opted to exclude like details about the project just to preserve intellectual property and make sure that nothing comes out before he has a chance to patent it.
Which is pretty exciting. And then the last student we'll hear from is Ryan Kent from the Robo Dreadnoughtus team.
Hi, I'm Ryan Kent. I'm an electrical engineering major and was on team Robo Dreadnoughtus. Basically what we did was build a mechanical Dreadnoughtus tail that allowed our customer to study the dinosaur's tail. As Dreadnoughtus are extinct, you can no longer study a living one. So what made our team unique we had two things really. We began as Team Robospinosaurus with the idea of creating a mechanical Spinosaurus to study how it moved on land and water. But however, our customer, who's Dr. Lampion Kennard, an RIT professor, introduced us to a paleontologist who is Dr. Ken Lacovara as a subject matter expert and additional customer, and he recommended that we switch to Dreadnoughtus as not enough was known about Spinosaurus. And this is about halfway through our first semester. So we switched our project entirely, meaning we didn't have any customer requirements or anything like that. So we actually created our own customer requirements and then sent them to our customer for approval, which is backwards from what most teams do. You're typically given requirements that you have to meet, but we created them, sent them for approval, and then our customer modified them a bit. And additionally, we had Lockheed Martin engineers as mentors, and they attended every design review and scheduled additional meetings with us to help with our design. This really changed design reviews. Instead of us just giving information to our customer, it was much more of a back and forth discussion about our design, as we would present a subsystem and then ask the Lockheed Martin engineers what they thought about the subsystem. They'd give us feedback. And really that gave our team, great confidence in our design that the finished product would actually work. And confidence is probably one of the most important things when designing.
Great, thank you. So the next thing we're going to share with you is team lightning talk. So at the end of each semester, well, let me back up for a second. During the course of the 2 semesters, the teams have design reviews. They do a design review with their client roughly every 3 to 4 weeks. So then at the end of the semester, and instead of having them do a big presentation again, we have them create a 2-minute lightning talk, which just gives a brief summary of the project. We're going to share lightning talks with you today for 4 of the 5 teams, not the X-ray improvement process, because of, they want to keep it confidential, but we'll share the other 4 with you. And if you want to see more, we do have a YouTube channel, and the link that I believe is going to be shared in the chat will link you to a page that we have where we keep a sort of a summary highlight of each of the projects that have run during the previous year, as well as links to the YouTube videos where they're stored online. So you can binge watch them during your holiday break this year.
Hi, we're ROAM, or the Removable Overhead Obstacle Avoidance Module team. So what is ROAM? It's a removable device which can be attached to the guide cane of a blind and visually impaired individual and can detect objects above their waist and notify the individual of their presence. The device is being made for the Association for the Blind and Visually Impaired, or ABVI, a nonprofit which supports the blind and visually impaired community. The device detects objects and sends vibration to the cane that are scaled to the object's distance. It's also rechargeable, has a clip for easy attachment and detachment, a toggle switch to toggle between indoor and outdoor modes to vary the detection distance, and a buzzer for low battery indication. It is special because there are a lot of solutions out there, but they're a lot more expensive, or they require a major change to the guide cane. Our device has a target total cost of $30 and does not require these modifications. The sensor needed to detect an object as thin as a pencil at a distance of about 2 strides away. The software was a custom software written in C to control all the electronics, as well as filter the sensor data to improve sensitivity to small objects. The PCB is a custom printed circuit board, which was designed to integrate all the necessary components. The attachment mechanism is an off-the-shelf component which is easy to use and attach and detach from the cane. On the left, you can see our fully populated PCB, and on the right, you can see that PCB integrated with the battery into our housing, into the prototype housing rather, which was then sent to ABVI, where we tested with 5 blind and visually impaired individuals with obstacles such as small, thin wooden dowels to see if they'd stop before hitting the objects. The prototype was very positively received. On the right, you can see an image of how the prototype would look on the guide cane. There are a few outstanding issues, such as the lack of longevity testing, the fact that the battery life was not tested, buzzer software that has bugs in it, as well as a charging circuit, which is not functional. Here's our team, and we'd like to thank ABVI, our customer, as well as Mike and John, who are our guides who supported us. Thank you.
The RD UVC system, developed by Sterilize LLC, is a portable device used in hospitals throughout the United States and Canada that eradicates dangerous pathogens in medical facilities using UVC radiation. The system utilizes wireless sensors to measure the UVC radiation dosage from the emitter, streaming dosage information to the cloud to verify proper exposure time for effective disinfection. The task for Team P285, the COVID Crushers, was to improve the emitter and sensor localized positioning to verify proper room sterilization, keep track of tower location within the hospital to improve user interaction, and improve the lifetime and durability of the sensors by implementing inductive charging. This project was broken down into 3 main subsystems. The tower mapping subsystem used Wi-Fi access points and their corresponding signal strengths to determine the tower's current location anywhere in the hospital. A barometric sensor was additionally used to help differentiate between changes in altitude to determine the floor that the tower was located on. The room mapping subsystem used the LiDAR and millimeter wave technologies to best determine where the technicians should place the UVC sensors in the operating room for optimal disinfection. Both the LiDAR and the millimeter wave are technologies that work on the principle of radar to determine location of objects in the 3D space. The LiDAR utilizes light from a laser, while the millimeter wave utilize short wavelength electromagnetic waves using an array of transmitters and receivers. And finally, the inductive charging subsystem allowed for wireless charging capabilities for the UVC sensors to reduce the wear and tear that traditional contact-based charging can cause. Contact-free charging is implemented with inductive power transfer to charge the lithium-ion battery in the sensor unit when it is sitting in the base of the tower. Future work for the project would consist of an improved inductive charger design and LiDAR system, along with improvements to the calibration sequence for the barometric sensor to detect changes in weather or operating room conditions.
Gait training is a physical therapy procedure in which a patient, in order to recover from an injury to the legs, progressively applies more pressure over subsequent appointments to re-strengthen their ability to walk. It is a largely qualitative procedure in which the physical therapist and patient must both provide constant feedback, and where re-injury due to accidental application of too much weight is somewhat common. The goal of our project was to create a device meant to be used in conjunction with a standard hospital boot, which could make this process more quantitative in order to be safer and more effective in the recovery process. Production of this product needed to be completed with a focus on cost effectiveness, durability, and ease of use. An orthotic device composed of 3 basic components was decided upon: a footpad sensor composed of dragon skin silicon rubber and an array of TechScan Flexiforce pressure sensors would intake patient weight data. A handheld device containing an Arduino Mega 2560 Rev 3 would intake patient data via a touchscreen. This data will determine the parameters for the procedure. This device also provides visual, audio, and haptic feedback to inform the patient and therapist as to the status of the procedure and whether the patient is applying too much weight. An Arduino Nano 33 BLE transmits the weight data via Bluetooth connection in order to ensure ease of use of the device. Both Arduinos are contained in 3D printed cases for the ease of manufacturing. These designs maximize on patient comfort and ease of use while conforming to all customer requirements.
In an attempt to answer the question as to the capabilities of the Dreadnoughtus, and more specifically, the function of the chevron on the creature's tail, a scale model was developed which would allow for an investigation into the forces and constraints at play.
Tail movement can be estimated as an arrangement of elastically connected compound pendulums. We began the construction of a mechanical model based on skeletal and muscle estimations, limited to 1 degree of freedom. This was accomplished through the manufacturing of CNC aluminum vertebrae with widely adjustable muscle connection points and sensor mounts. The links are interconnected with bronze bushings, nylon thrust washers, and spring-back mechanisms, including both torsion springs and a rigid Delrin rod held in place with 3D printed guides. These measures were taken to provide a tail swing similar to that of the Dreadnoughtus.
The base and tail mount of the test fixture were constructed out of plywood, allowing the tail to be screwed onto the mount. 80-20 aluminum rails were then fastened onto the base of the test fixture to allow for the force plate to be attached and adjusted as necessary.
2 force plates are mounted on 80-20 structures of a test fixture by solder screws. An impact sensor is mounted on the force plate, and the tail could swing and hit on the other plate, so that the team could connect data about tail movement from the sensor.
Accelerometers, flex sensors, and force sensors were added to the tail in order to measure and ensure that the forces exerted on and by the tail are reasonable. Through hand calculations, we learned that an accurately scaled dinosaur bone would be able to withstand 1,500 pounds of force, far more than our prototype can manage.
The robotic model of the tail and data acquisition is controlled through a graphical user interface, or GUI. The GUI is built with processing and ID for Arduino GUI development, and displays the input from the user and interpret signal from processing to Arduino using USB serial communication.
Electrical solenoids and steel cables replace muscles and tendons. As similarly to muscles, solenoids pull with an increasing force as the distance remaining reduces. The contraction of the solenoids results in whip-like movements of the aluminum links, demonstrating what Dreadnoughtus might have been capable of.
So at this point, what we'd like to do is open up the floor to questions. So we'll ask that you put your questions in the Q&A box, and Don's going to start asking questions, and I'm going to monitor the Q&A and pass along questions that you type there. It looks like we've already got some starting to come in, which is pretty cool. So I think we're going to exit the slideshow now, and so that we can see all these students as they respond to their questions.
Okay. So I prepared some questions to get us started off with, so we'll see how this goes. So to the Rome team, Owen Carr, thinking back to the MSD1, what system design tools and processes did the team find most useful in defining the design?
Yeah, I think initially having that exercise to really shake out what the core customer and engineering requirements were something that, as the team progressed with the project, became more and more beneficial. And we realized how beneficial it was as we moved on with the project, because so many times, especially working with an outside customer, you can have an issue that they want you to address, and the nitty-gritty of the exact requirements that they want you to address often can be a little bit muddled. And so having that iterated improvement of customer and engineering requirements really allowed us to hone in on what exactly we needed to be targeting, and what types of systems exactly that we needed to be designing.
Cool. Thank you, Owen Carr. So I got one for Josh, COVID crushers. Which new technology that you work with was the most challenging, and why?
Oh, that's a hard question. I think the most...
These are supposed to be easy questions.
I knew you were going to do this to me, Don. I think probably the Wi-Fi tracking was probably one of the hardest technologies, if not the inductive charging system. Just because the other technologies that we worked with, we had some experience with, or there was good documentation to complete. But with the inductive charging system, we found out that a lot of the kits that were being sold out there weren't easily configurable to the needs that we had for our requirements and constraints. And then for the Wi-Fi system, it was a lot of research to see how do we kind of remove outliers and weak data that was collected to get some feasible performance.
Okay, thanks, Josh. How about one for the weight-bearing monitors? Ethan, there were some issues clarifying PPE requirements to handle a resin. Can you describe how that affected your schedule and how it was resolved?
Yeah, so the resin part was going to be our main mold to encase all the electronics when we put it into the foot pad. And so really challenging that. The real difficulty occurred when we were trying to get a specific resin from a company. And I think we were thinking too advanced in that case. And so we resolved it really by, as we started to notice that it was taking too long to get this other resin, we started to search out again. And we tried to come up with something really quick, and we tried to bring them back and go for the simpler solution. It was kind of like an Occam's razor situation, where we could find a mold that is both with silicon-based mold, which would be great for electronics to reduce conductivity, and while also being stretchy and flexible. And it really just came to mind that a lot of artists and makeup artists and things like that would make molds, and that's where we came down with the dragon skin.
Yep,
pretty good.
Thanks, Ethan. John, for the X-ray improvement team, how do you feel that your team benefited from the project and the MSD program in general?
Speaking in relation to the co-op experience, a lot of us enjoyed it a lot more because we had all been on co-op before. Yep. And it felt much more realistic in that we were kind of defining our own tasking. And with everything being online, it was like a kind of self-paced transition into the workforce, where we have had standard, traditional, however you want to call it, engineering experience. And now with everything being online, remote work from home, that kind of thing, this was kind of our segue into it, so that when we do end up in the workforce and it's maybe 50-50 in the office and at home, we're a lot better prepared for it. Just used to Zoom meetings and screen sharing and all these technologies that make everything so much easier.
They do. We've learned a lot on how to use it, haven't we? So for Ryan, Robo Dreadnoughts, what insights did your outside mentors offer the team, and how did this influence the team's decisions?
I would say a lot of the insights they offered were things that you don't really have to think about from a theoretical standpoint. So when you're designing something mechanical, you don't really, from a theoretical standpoint, you don't have to think about how you're actually going to build it. You just think about what are the forces, is it strong enough, and everything. So they offered a lot of different insight into how to machine things, how to design to machine things as quickly as possible, as well as designing things for strength. I remember some of our designs had really small wall thicknesses, which they recommended we increase. And I also feel like they did a very good job of reminding us to keep our design simple. You can make things more complex and it might look neater, but the more complex you make a design, the harder it is to actually manufacture and harder to debug. So they did a really good job of just reminding us to keep things simple.
Okay, thanks, Ryan. So for the Rome team, could you please speak about the focus group testing? Were you present when the device was tested? How did you coordinate the session? And did you have the users try more than one iteration of the device?
Yeah, so this was a pretty unique experience for us, just given, so it happened in November. We were in that hybrid state here at RIT, and we had spoken to our customer about how many we could send, because we couldn't have the whole team there, right? So we had 2 team representatives there to help conduct the testing. We had a whole test plan ahead of time, but it was a different dynamic when we were working with the folks who we had there, the blind and visually impaired. And so essentially we worked with our representative who was at ABVI. We had set up 5 20-minute sessions with 5 different people of different age groups to test this device. And we only did 1 iteration just because we had other iterations planned, but the required time to get the PCB and all the different parts assembled just led to a really long lead time. So we tried to pack in as much as we could into this 1 session, which led to us testing a number of different pieces of the device's functionality, like its ability to detect objects at a far enough length, its ability to detect small enough objects, its ease of putting on and taking off the device, because that was still important as far as the general usage of the device. So yeah.
Great. Thanks, Omkar.
Mm-hmm.
So here's a question for all teams. Do you think working remotely has changed your team dynamic or work plan? And have there been any benefits to it? Anybody can answer that one.
I could take the first stab at it. During the spring semester, it was definitely the change in pace really made us focus mostly on design and not touching any hardware or any physical coding in that regard. So it did come in handy, forcing us to basically look more into the future and kind of document a lot of the steps that if we missed any before, to definitely document them now.
Okay, anybody else?
Yeah, if I can say something, I would say that it made our meetings much more efficient and much more, like planned. when you just meet in the senior design room for 3 hours twice a week, you don't have to be as focused on what you're going to talk about. You don't have to plan everything out as much because you have 3 hours. Most things will come up. But if you just sit on a Zoom meeting for 3 hours, it's sort of awkward. So my team, we'd have agendas going into our Zoom meetings. We really had to focus on making sure everyone talked, making sure no one was shut out. And it really, I actually think it helped us in the design phase as we could, we were just more efficient in talking about our designs. Our meetings ran way more smoothly and they were much shorter. So we could finish talking quickly, then we could go work on something for the rest of the 3 hours. Then next meeting, the beginning of it, we could go talk about what we did.
Cool. Thanks, Ryan. Anybody
Yeah,
else?
kind of on that tangent, when you meet in person, you have a tendency to, like, things happen naturally. And so you might miss something like measurements or something vital. And then one meeting, 2 meetings down the line, you're trying to remember a measurement or something that you may not have written down just because you're running out of time. So this way, everything, at least for our group, because we started online and we really kind of dug down during MSD1 and tried to get some good habits going. So we have like meeting notes, and like they saved us later on, like, because we had to revert some of our design choices or go back and find different sensors. And we had to like go back and find what our initial requirements were in terms of size, like things that we had found by trial and error that we would have otherwise forgotten and had to redo. So just having that extra layer of documentation was actually super helpful.
Yeah, thanks, John. Anybody else? Because I have other questions to ask. Okay, I got one for the Rome team. Is this device lightweight and balanced enough to not be overly heavy when mounted on the cane and imbalance the user?
Yeah, so this is a pretty important concern for us throughout. And when we presented it, the best way for us to figure that out, right, is just to hand it to the end user and have them apply it to the device and let us know what they think of the weight. And in every single one of the folks that we talked to and interviewed, they said that it was light enough. And we did that through intelligent, packaging, making sure things were as in line as possible, such that they were in line with the cane, so that you didn't create any adverse moments by having some weight off to the side. But just in general, like all the components were on such a small scale that we were able to keep the weight down enough such that the weight and feel of the guide cane was similar enough to the guide cane without the device.
Yep. Okay. Thanks, Owen Carr. Question were there any teams tempted by feature creep? And so you know what that is, right? Feature creeps, new features that came in and bound along during product development. And if so, what were they? But more importantly, how did you handle it? And then the flip side would be, once you got through the feature creep concept, were there other features that you wish you would have been able to get to? And how did you manage that process? That's open for anybody.
Yeah, for our team, we didn't have too many feature creeps that our customer kind of tossed at us, but one in particular that stands out to me is that we had a keypad to enter numbers, and that's for like all buttons for any entry part. But what he wanted was a quick way to kind of click on a button and then click another button to set a fixed number. So like if you want to change the percentage to 25 to like 50, they kind of have like those set devices. And with the instruments that we're using, it didn't have the greatest interface. So I think what we really did was communicate to him that's like, hey, it's not that easy of a task to do. And we'd rather focus more on the main features that we were still hammering out. And so we made it clear to him that we'll put it on the back burner. If we have time, we would get to it. And he seemed okay with it, as the general solution like helps for all types of number entries.
Okay, thanks, Ethan. Anybody else want to attack that one?
Yeah, we had a few peripheral functions to our device that we wanted to integrate to and that our customer has suggested. Something in the range of like having an accelerometer on the board so that you could detect if the device happened to fall and then coordinate that with a beep, with a buzzer, a beeper. And really what it came down to is like what was critical path for us to deliver like a solid engineering model that did the main function of the device. And so a lot of that stuff fell to the wayside or happened a little bit later on in our design process, where we spent more time focusing on what was, important, making sure that that sensor reliably detected device and sent the feedback to the users reliably. So we spent more time with that. And then when we had other time, we dedicated that. But definitely something we saw ourselves challenged with, especially with COVID and dealing with the outside customer.
Okay, thanks, Owen Carr. Anybody else? Because I got more questions.
Yeah, I think one feature that stuck out to me that I guess creeped up on us a little bit was just how to improve the overall process when trying to track the location of our tower in the hospital. So our client would come and say, well, what if we added an additional technology like an accelerometer to be able to detect when the tower would pass through doorways or change floor levels as a form of kind of resetting calibrations and get better accuracy. But as we kind of went through the process and tried to really prioritize what were our core requirements and what was definitely needed for the time we had, we ended up pushing it as a future scope if we ever got around to it.
Great, thanks, Josh. Okay, I'm going to move on to another question. The weight-bearing monitor is intriguing. This is from the audience. I wonder if there are applications for running shoes with regard to enhancing techniques with foot stride. So what other applications may there be with this weight-bearing monitor?
There were definitely a couple of technologies that we found while doing the initial prototypes and designs in the first semester. And one of the primary problems with those types of foot sensors was that they don't last too long, basically from all the force that you put onto a running shoe as like an athlete's working out and doing things with it. And so we took that into account with how we picked a lot of the resin and things like that. And so I guess the major problem for any type of application with that is how long and the durability of the sensors.
Okay, thanks, Ethan. So for the X-ray team, relative to your patent scope, is the patent that your customer wants to file USA, other countries, or some attempt at a global patent? Is he looking for worldwide coverage? Can you speak about just what kind of coverage from an IP standpoint that your customer is interested in pursuing?
Yeah, sure. From what I understand, he's looking initially, just our working prototype was a machine called the Air Techniques ScanX, which is just one company. But we also made kind of like a casing or a clamp that could attach to the X-ray machine. And with regard to that, that could be customized ideally to any X-ray machine. So I think to answer your question in the shortest form, for right now, patent would be US only. But X-ray machines are similar enough that the ideal situation would be a global product.
Is he intending to market this product worldwide, do you know, or other countries?
Across the US initially, and then worldwide.
Okay. So virtual teams are interesting. What project management software did you use in the process of keeping the team's tasks, et cetera, moving forward? This is a really good question.
I'll start with this one. So initially for MSD1 in the spring semester, we started with a software called Trello, which is basically just it gives you a bunch of boards and cards you can divide activities for. You can move them around to different statuses as you go. So that initially helped us with keeping track of what activities we needed to complete for documentation, what our deadlines were coming up. But then moving into MSD2 this past fall, we moved to a software called Monday, which was basically the same thing as Trello, except it gave a little more features with being a little more organized, adding deadlines more specifically to items, be able to figure out who's working on them, give like task updates and descriptions to each thing. So I think that really helped us with our process. In addition, we use generic things like Google Drive and GitHub to like manage all our files with the Confluence wiki pages that we were managing.
I can echo Josh's discovery of Monday. We started with that initially and it really came in handy once we all went virtual and online.
I can not echo the other two. We didn't use Monday, and we also did not use Trello. We created a Gantt chart in Google Sheets. It was just in Google Sheets that everyone had access to it. They could edit it themselves. We're also pretty strong spreadsheet, Excel programming language, if you count it as programming language. We're all pretty strong in it. So it moved each day. We had like a bar that moved each day whenever a day passed, and then we had deadlines. Upcoming was green, active was yellow, late was red, complete was gray. So it was really easy just to look at all of that. And then we used GroupMe in order to notify each other when we needed to, when we were starting something or when we ended something. So it was, as opposed to something like Monday where it notifies everyone when you complete something, you just check it off on Monday and it sort of tells everyone. We just relied on us completing a task, marking it on our spreadsheet, and then telling us in the GroupMe what was going on.
Don, we're not getting your voice.
Sorry, I have two mute buttons. Earlier on in the discussion, we talked about intellectual property and how projects that are sponsored, and if the sponsor wants to own the intellectual property, that we make an assignment. Beth, could you talk to us a little bit about what the RIT policy is with regard to students owning their own intellectual property?
Sure. And it's an important point, and this came up in the chat a little bit earlier in the session also. So RIT policy says that students taking undergraduate students taking a class reserve the right to own any intellectual property that they create. So, but we have a lot of industry clients who, if they're going to sponsor a project, they want to be able to use the outcome. So what we do is we give the students a survey before they come to the class where they give their project preferences, but they also indicate there if they're willing to be assigned to a project where they would be asked to assign IP or not. And then I assign teams based on the student's response to that. So when a company sponsors a project, the students that are assigned to that project are those who had indicated, yes, I'm fine with being assigned in a situation where I'll be asked to assign IP to the client. And that does happen on quite a few projects. In fact, 4 of the projects here are going back to the client with some sort of effort to try to commercialize it. But the default, if we do nothing, is that the students own their IP. So we have an option built into the program.
Thanks, Beth. Okay, so this is for any and all teams. Did the team members know each other prior to the project start? And given the high percentage of virtual communication, did you actively do anything to help develop the personal relationships that can be so helpful to forming the team and getting the team to go from forming, storming, norming, performing?
I could take the first crack at this. I was one of 2 computer engineering students on my team, but I'd only ever had one class with that student. And then there was a biomedical engineer, and then Mouj, who's in Dubai. Clearly we had no interaction, but it was just, we did our best. It was kind of interesting for us because we started online. So a lot of our interaction to begin with was virtual. So we had a few sessions through Zoom with webcams, and then we all kind of felt more comfortable just in a voice and like texting environment. So we exchanged phone numbers, and then we used Discord. So we created a channel for us students only. And we just kind of talked back and forth about classes and everything, and just kind of bonded through that.
Anybody else?
Yeah, I'll take a crack at it. For me, I only had, so my team consisted of 2 computer engineers, me being one of them, and I knew the other's computer engineer through some classes, but then the rest of my team was heavily, the rest of them were EEs, electrical engineers, there were 6 of those, and they generally knew a few of each other from other classes. So we didn't necessarily do any additional activities, I guess, to get through that bonding phase, to get through the forming. I think actually all of us on the team, we kind of all just clicked. All of our interests kind of worked to the way we wanted to divide into the different subsystem implementations, which worked out really well. So everyone was ultimately happy with what they wanted to work on, and everyone got a good contribution to a different phase of the project.
Yep, thanks, Josh. So let me try another question here. This is for all the teams. These MSD projects are required to exercise your capabilities in many dimensions: technical, learning and knowledge, process skills, project plans, budgets, etc., team dynamics, customer-client relations, managing your mentor. Is there any one area that stands out as a bigger learning experience for you or your team?
Oh, go ahead.
Go ahead.
You can go ahead.
Alrighty. I was just gonna say, especially getting towards MSD2 and having to actually put this thing together. I think the biggest learning curve for a lot of us was just like the lead times involved with projects that have real impact like this, when you're trying to make something that actually works and doesn't work for a couple of things and breaks. Ordering PCBs, ordering parts and stuff like that, doing the proper processes gave us a little kind of preview of how important doing our homework ahead of time was as well. So like making sure we dotted our I's, crossed our T's, so that when we did put in the order for something, and when we did, request something from a supplier or something like that, we got the right thing on time, so that we had a successful project. Because I think we did initially have some pitfalls where we like ordered the wrong component, and so we kind of learned the hard way that way. But learned it early so that later on, when we did order parts that were critical to our like final prototype, we were able to do so in a pretty consistent manner.
Cool. Thanks, Owen Carr. Ethan, you were going to say something.
Yes, for our team, I think the biggest learning curve for all of us is the team dynamics. I think we lacked a pretty strong leader in the beginning, and it didn't really help throughout the second semester as well. And I've now gained more of a greater respect for a strong project manager and someone to hound you on deadlines and things like that. And I think it would have helped us a lot to have somebody that would really keep us on track, kind of crack the whip, if you will. Hit us with the stick.
So I got a follow-up question for your comments, Ethan, is kind of related to what you were just talking about. The question is, how did your guides support your teams?
Our guide was helpful in keeping us on track with a lot of the MSD procedures, and made sure we didn't like miss any of those the small nuanced details, such as with the Confluence pages, and making sure we filled all those out. But he was pretty hands off when it came to team dynamics and things like that, and where we got into the nitty gritty of the engineering.
Yep. Okay. Thanks, Ethan. Anybody else? Oakmar?
Yeah, if I could jump in real quick on the topic of guides, we actually had like a unique experience with 2 guides, one who was training the other, with John training Mike, and then Mike taking over. And it was actually pretty helpful having both of them there, having both of their experience. They helped us a lot when COVID hit, and helped us move the needle, move progress forward by getting us the resources we needed to actually make measurable and important progress during MSD1. And then during MSD2, I thought our guides were a pretty good consultant, at least for me, from the mechanical side, when we looked to at least start our research with injection molding and stuff like that. He had experience in the industry, so it was pretty helpful.
Okay, thanks, Omkar. Anybody else?
Yeah, if I can make a comment. So the guide for my team was excellent at asking us the right questions to get us thinking. A lot of times we'd get sort of stumped with our thoughts or what we should do, and he always had a question that made us figure out the answer ourselves. which really, made the work feel like it was our work.
Great, thanks, Ryan. So with regard to the timing, it's 5:55, 5:56 p.m. Beth's got some closing comments, but what we're going to do, if you're willing to stick around, is after she goes through her closing comments, we're going to continue on with the Q&A sessions because we still have several more questions from the audience that maybe the students would like to answer. So Beth, you want to go through your closing comments?
Yeah, and actually, while we're bringing up the PowerPoint, if the students want to go real quickly, because I know we are getting short on time, if you don't mind, tell us what you're doing after graduation. Josh?
Yeah, so I am working with a medical software company right here in Rochester. So I'll be working here from my house, giving them some nice software to work to play with.
Cool. Owen Carr?
Yeah, so I'll be an incoming 2021 VFA Fellow, Venture for America Fellow, which is a fellowship designed for startups in non-traditional startup cities.
Cool.
Great. Ethan?
For me, I'm currently doing my master's program. And so that's the foreseeable future for me to make sure I get that thesis out and hammered away. But I eventually want to end up in industry.
Great. Ryan?
I am an analog integrated circuit engineer at Vicor Corporation, and I start that January 18th.
Great. And John?
I'm going to be doing a systems engineering role outside of New York State. Talking with 2 employers now, hoping to get a response back and get working mid-January as well.
Great. Thanks, guys. So thank you to the students. I appreciate these. So the semester's over. They're totally off the hook and they've completed their undergraduate requirements. So they did not have to do this. So I appreciate them taking the time to come and tell us all about their projects. So in closing, if you're interested in getting engaged with the program, we've got a lot of different options. As Don said, we do close to 100 projects a year. So probably the highest demand way to get engaged with the program is to propose a project from your company where you're working or something else. We've had some folks propose projects for a side endeavor. Our spring start projects start in January and they end in December. We're now, thanks to John's team being our guinea pigs, we're going to do a regular summer offering that will start in May and finish in December. And our biggest group, which is probably close to 400 students, those students start in August and they finish in April. And the proposals for that are due in June because it takes us a while to get things started. So the propose a project link is in the chat. And if that's something that you're interested in, take a look. There's a flyer with some information, basic information about the project and a link to submit it. Another way to get engaged is to provide subject matter expertise or mentorship to a team. You heard from the Robospinosaurus team, which got connected with Lockheed for a fairly formal mentoring arrangement. We also have alums who come in and talk to a team for an hour, or they'll do a quick workshop or record a video with us to provide subject matter expertise on a particular topic that's near and dear to them. You can provide funding for a team. So some of our sponsors will which we'll talk about in a second, will provide funding for a team without looking for a prototype in return. And that's important for a lot of our student proposed projects and our more community oriented projects. And last, and probably the easiest one, once all of our restrictions are gone, is come visit the Senior Design Center. Like Dean Edwards said, it's a pretty exciting place to be, especially in the spring when all these students are finishing up their projects, just to see the hard work come to fruition with prototypes appearing on the tables and the workbenches. So come pay us a visit when you're in the area. And thanks to Zoom, we can do this and you can at least see a little bit of what's going on virtually. And so I want to thank the folks who helped make all this possible. So we get a lot of support from folks on campus. That includes the technical staff from the Mechanical Engineering Shop, the Brinkman Lab, the Construct, the Electrical and Computer Engineering Senior Design Labs, the MSD staff, which includes guides, Gary Hodenius, who helps us out in the shop, Christine Fisher, who runs the MSD office and handles the financial side of things, and all of our student lab assistants. Dean Edwards provides support for the program and the faculty and staff in the College of Engineering provide subject matter expertise and train the students, teaching them in the classes up until they get to this capstone experience. And then finally, our IT partners outside of the College of Engineering, folks in other departments, folks like Alumni Relations who help us put on webinars like this, which is a great help. And then I want to thank our sponsors and clients for this group of students. As you can see, it's a pretty wide variety. We've got large corporate sponsors, we've got community organizations, and we've got a few individuals, as well as folks on campus and off campus. And then finally, thank you to our donors. So these folks, individuals and companies, have provided more general support for the program, which allows us to direct the funds to a variety of different places. And typically this funding goes to support projects from faculty, projects proposed by students, or from student clubs, and projects that have community impact. And so we've got several individual donors, Jim Swift, Jeff Bank, Bill and Sally Hard, John Kamerlin, Bernard Student, and then we've had gifts from Cortera, L3 Harris, Texas Instruments, and Lockheed Martin, and that support helps to keep the program running. And with that, thank you for coming. I think we're going to stop the recording, but if folks want to hang around and ask a few more questions, we do have a couple more questions waiting in the chat. So thanks for coming, and thanks to the students for participating.
Okay, we still got a couple more questions if we'd like to continue the conversation a little bit. For any of the teams, I think we got our panelists still here. For any of the teams, were there any specific team dynamic challenges that you faced, and how did you handle it? And if you say none, I'm not going to believe you.
I would say off the bat, at least for our team, when we did the DISC assessment, like the personality tests, all of us, I think, except one student, just came up with S, and like it wasn't even close. We were all just steady, and all of us were kind of used to autonomy, but not experienced leading. So it was just trying to assign roles and kind of figure out how we would go and work moving forward.
What if it was the other way around? Everybody was D's and I's.
We probably wouldn't have gotten a proof of concept working.
Anybody else? Okay. Let's see what else we got. Okay. Beth, are any other questions in Q&A?
I think there was one other question came up, and I think the person who asked it is actually gone, but I think it's related to the last question that just came up, was what was the most challenging relational issue that came up? So I think that, it's a team dynamics question. So we may actually already have answered that, unless anybody wants to add something.
Yeah, I think most of the teams were kind of lucky to, I can say for my team that we were lucky that we were pretty comfortable with each other. And so no one really stepped on each other's toes or had any personal beef with anyone else. We kept it professional.
So I have a question for the teams. And the question is, now that you've been through MSD 1 and 2, did you learn more soft skills or hard skills through this process? And what do you think?
I have to say I learned a lot of soft skills, specifically with the team leading and having those team dynamics and making sure those are pretty straightforward, and at least how I work as a individual in a team as well.
Yep. Anybody else?
Yeah, I think.
No, you go,
Right.
go, Josh.
I think to go on to what Ethan was saying, I think it was a lot more soft skills. I think the biggest takeaway I had was the importance of documentation and traceability, to be able to go back at any point and see, okay, this is what we talked about. These were kind of our conclusions from it. And it just made schedule tracking so much easier, and making sure that we were always on pace with what we needed to do for that.
Yep. Anybody else?
So we've got some congratulations coming up. We had some nice job. It's great to have you represent RIT as you move forward with your next career steps. And I can't agree more. We're proud of you all as we send you out into the world to represent us. I think we've had one of our student participants had to go. He had another commitment, and I think our captioner has had to leave because we have run over time. So I think since we've cleared the question queue and we had some really good questions, I think we're probably going to wrap it up here.
Nice job, everybody. Congratulations.
Very nice job. Thanks, folks.
Thank you.
Yeah, thank you. MSD was fun, so thank you.
We've got that on a recording.